What's up everyone, welcome back. Patrick here, and moving on to the next example, we got to find f prime a, or the derivative of this function 3 over x squared, and we have to use both of these definitions over here. Okay, so if you're not using this alternative definition that I introduced for f prime a for the derivative or the slope of the tangent, then you only have to watch the first half of these next couple of videos where I find the derivative using this definition. But if you are also using this alternative definition, if your teacher or prof is using it or your textbook, then I'd recommend watching the full video, because you never know. On a test, they may ask you to find the derivative for a function with this specific definition or this specific definition. They'll mention it. So make sure that you're practicing both. And I'm going to show you how we get that same derivative, f prime a, for a bunch of functions in the next couple of videos using both definitions. So the first definition, we got the limit as h approaches 0 of f of a plus h minus f of a all over h. So if we plug in a plus h for the x value here for the function we're working with, f of a plus h would be 3 over a plus h squared minus f of a, which would be 3 over a squared, right? If we plug in a for the x value. And then this is going to be all over h. So notice we can't plug in a h value of 0 yet because of this denominator here. Now, notice that we got two fractions here that we're subtracting. So what we're going to have to do is combine these into one fraction, and then we're going to take that fraction and divide it by h. And that's the same as dividing by h over 1, which is the exact same thing as multiplying by 1 over h. And whenever I get something like this where I got multiple fractions in the numerator, instead of dividing by h, I actually like to rewrite it as multiplying 1 over h. Just personally, I feel more comfortable doing that. Just make sure that you separate that term from that whole term. You got to put that whole term in brackets. Okay, so what's going to happen now is to combine these fractions, we have to get a common denominator, right? Notice these denominators are different, a plus h squared and then a squared. So this denominator here, we got to multiply by a squared, meaning the top we got to multiply by a squared. Then this denominator here, we got to multiply by a plus h squared, meaning the top we have to multiply by a plus h squared. Okay, so if we combine all that, we'll have 3a squared minus 3 bracket a plus h squared. And now we got a common denominator, so put it all in one fraction. We'll have a squared, a plus h squared. And this is going to be multiplied by 1 over h still. And what I'm going to do is I'm going to expand this entire numerator, because we have to simplify that numerator and see if we could cancel out this h here at the bottom. So then we could plug in that h value of 0. And then this denominator, we're actually not going to be really doing anything with that. There's nothing that's going to really cancel out. So I'm going to keep it like this. I'm not going to waste time in expanding it. You can if you want, but I wouldn't recommend it. We could just keep that as is. But this whole numerator we got to expand. So what we would have to do is we'd have to FOIL out that a plus h squared, which would be a squared plus 2ah plus h squared. And then there would still be that negative 3 in front. So then that negative 3 we'd have to distribute to all of that. So we'd end up with 3a squared and then all of this here. So after we distribute the negative 3 inside that bracket, this FOILed term, we'd get negative 3a squared minus 6ah minus 3h squared. This is still going to be multiplying by 1 over h. Okay, so now what can we do? Notice how the 3a squareds here cancel out. Right? So those net out to 0. And now notice we got negative 6ah minus 3h squared. And notice we can factor that. What can we factor out of those two terms? We could take out a negative 3h. What would we be left with? We'd be left with 2a plus h. This would be all over a squared, a plus h squared. And this is going to be all multiplied by 1 over h, like that. Yeah, looks all good. So we took out a negative 3h from these two. 2a plus h, right? Negative 6ah divided by negative 3h gives us 2a. Negative 3h squared divided by negative 3h gives us h. Now notice we're multiplying all these terms, negative 3 times h times 2a plus h. So we could cancel out those h's there. And now with all the remaining stuff, we can plug in that h value of 0. So this would go to 0, and then this would go to 0. So we'd be left with what? Negative 3 times 2a, which would give us negative 6a. All over a squared times a squared is a to the power of 4, right? Because this would be a plus 0 squared, which is just a squared. And a squared times a squared is a to the power 4. Notice we have a to the power 1 over a to the power 4. So 1a up top, 4a's at the bottom, meaning that we're left with 3a's at the bottom. So negative 6 over a to the power of 3 is f prime of a of that function. And now we're going to do the exact same thing but using the second definition. And we should get that exact same value, negative 6 over a to the power of 3. And what's nice with this second definition, there's actually going to be less work. Usually this second definition, there's less algebra than using the first definition. It's just not as popular, right? That first definition is the more fundamental one, quote unquote. But what's nice here is it's going to be a little less work. So we got f of x, so we got 3 over x squared, minus f of a, which would be 3 over a squared, all over x minus a. Right? So a lot less terms to work with here. So what we want to do, combine these into one fraction. So we got to multiply this x squared by a squared, multiply the top by a squared. Then we got to multiply this a squared by x squared, multiply this top by x squared. So now we got a common denominator. So we got the limit as x approaches a of 3a squared minus 3x squared. And then that common denominator is a squared x squared. And this is going to be all over x minus a. Now, all over x minus a, since we're dividing by x minus a over 1, that's like multiplying it by 1 over x minus a. So I'm going to write that. You don't necessarily have to write this step. You can just keep writing that x minus a if you want. It's just, I like to show two fractions multiplying by each other versus taking a fraction and dividing it by another term. Personally, I just think it looks nicer. So continuing this up here, notice first how, I forgot to mention this initially, notice how we can't plug in an x value of a as x approaches a because we'll have a minus a, which would give us 0 in the denominator. So we got to get rid of this factor here somehow. And what we want to do is we actually want to simplify this numerator. So notice with this numerator, we can factor out a 3. I'll actually continue this up here because there's not as many terms. So we got the limit as x approaches a. We could factor out a 3 from both of these terms. So we'll have 3 bracket a squared minus x squared all over a squared x squared. And we're still going to be multiplying by 1 over x minus a. And then notice that this a squared minus x squared, that is a difference of squares. So we'd get 3 factoring that would be a minus x, a plus x. This is going to be all over a squared, x squared, and we're still going to be multiplying by 1 over x minus a. Now, notice that x minus a, this factor, and a minus x, they're almost the same, but they're not, because notice the a value is positive here it's negative, and notice the x value is negative, and here it's positive. So what we can do is we can actually factor out a negative from this bracket. So we'd bring that negative, let's bring it in front of the 3. And this a minus x would now turn into negative a plus x. All the signs would change, which is the same as x minus a. And then this a plus x stays the same. Remember, when we factor out a negative, we factor out from this bracket. We don't factor it out from this bracket as well, because we're multiplying all these terms. So that bracket here stays the same. All over a squared x squared multiplied by 1 over x minus a. And now what happens? X minus a's cancel out. And now notice we could plug in the a value for all the x's, right? Because we're not going to have that denominator 0 anymore. So if we plug in a over here, a plus a is 2a, so we'll have negative 3 times 2a. All over, and then for this x, we're plugging in a, so we'll have a squared times a squared, which is a to the power of 4. And notice that this is going to be negative 6a over a to the 4, which would be negative 6 over a to the power of 3. And notice that's the exact same solution that we got with that first definition.